few more examples with antiderivatives, picking up on the last video where I did the first 4 of these examples. In this video, I'm going to do the last 3 of these examples. I think these are a little bit harder, maybe. I don't know, maybe not. I just thought if I threw 7 examples all in one video, people might get overwhelmed. Hopefully this gives people a chance to breathe in between problems. Find any function again, so I'm looking for an antiderivative, meaning I don't have to tack on the plus c, so that the derivative of that function is 4 to the x power plus x to the 4th power plus 4. Bunch of 4's in here just to kind of be confusing, I suppose. What I'm trying to do is take the antiderivative of 4 to the x plus x to the 4th plus 4. How would I do that? Well, maybe the first thing you'd recognize is you have 3 different terms in here, so you can take the antiderivative of each term individually. I'll have to figure out the antiderivative of 4 to the x, and then I'll have to figure out the antiderivative of x to the 4th, and then I'll have to figure out the antiderivative of 4. Just like we did with derivatives, let's take this one hard problem and turn it into 3 easier problems. What's the antiderivative of 4 to the x power? That one's a little bit tricky. It's one you don't see too commonly, but maybe it would help to recall that the derivative of 4 to the x power is almost 4 to the x. You just had to tack on this natural log of 4. And so if the derivative of 4 to the x equals 4 to the x times the natural log of 4, then the antiderivative of 4 to the x times the natural log of 4 must be equal to 4 to the x, plus c technically. And since the natural log of 4 is just a constant, I can pull it out in front and say that the natural log of 4 times the antiderivative of 4 to the x is equal to 4 to the x power. And so if I was interested in just the antiderivative of 4 to the x, maybe I'd want to get this natural log of 4 over on the other side of the equation. If I divide both sides by the natural log of 4, I get that the antiderivative of 4 to the x is equal to 1 over the natural log of 4 times 4 to the x power. You don't have to memorize this or go through this derivation every time. I mean, we have this written as one of our rules way up here. Because of the fact that the derivative of b to the x is b to the x times the natural log of b, the antiderivative of b to the x is b to the x times 1 over the natural log of b, technically plus c. But if memorization isn't your thing and you don't have this memorized, my point is you don't really need it memorized. As long as you understand the derivatives, you can kind of come up with the antiderivatives. The point is, this first term right here is just 1 divided by the natural log of 4 times 4 to the x power. And yeah, you can put the 4 to the x up on the top of the fraction if you want. The reason I leave them separate like this is to try to show the work a little bit more, to try to help students see where this stuff is coming from. I guess technically there should be a plus c over here, so maybe there could be a plus c in here, but I'm not going to put a plus c here because there'd be another one here and another one here. And rather than write these individual constants, I'll recognize that the sum of a bunch of constants is just a constant and put it at the end of the whole thing. The good news is, of these 3 problems that we turned this one problem into, that was the hardest part. The antiderivative of x to the 4th power is not nearly as bad. You're thinking power rule? You're thinking to end up with x to the 4th power, I must have started out with x to the 5th power, but the problem is if I started out with x to the 5th power and I took derivatives, I'd bring that 5 down in front and get 5x to the 4th power, not just x to the 4th power, so I need a 1/5 out in front. A lot of books would write this as x to the 5th over 5, but again, I'm going to write it this way because I think that'll help students understand more where the pieces are coming from. Finally, the 4 is just a constant. When I take the antiderivative of the constant, I always tack on my variable, so I get 4x. If you're uncomfortable with that, take the derivative of 4x and realize that you get 4 as the answer. Therefore, the antiderivative of 4 is going to be this 4x. I already wrote my plus c, which represents any arbitrary constant. Although I guess technically this question said find any function, so I'm looking for an antiderivative, not the antiderivative. So maybe I shouldn't even put this plus c in here and just call this mess right here my final answer. What if the function that we're trying to find an antiderivative of is x squared plus 1 over 4? How would you deal with that? Well, hopefully you don't look at this and kind of think in terms of quotient rule and stuff. A, because quotient rule is something we have for derivatives, not for antiderivatives. And B, because you don't have to think about this as a quotient. Think about it as some constant, 1/4, times some function, x squared plus 1. I think written in this form, the problem becomes a lot easier. If we're trying to figure out the antiderivative of 1/4 times x squared plus 1, since this 1/4 is a coefficient, we pull it out in front of our antiderivative symbol. All we gotta do is take the antiderivative of x squared plus 1. Yeah, I guess I should show the step where I break that up into 2 different antiderivatives, but much like with derivatives, you'll quickly get to the point where you don't have to break this up into 2 different antiderivative symbols. You can just look at this and be like, the antiderivative of x squared, isn't that just 1/3 x cubed? Be like, yep. Antiderivative of 1, isn't that just x? Absolutely it is. So wouldn't the antiderivative of x squared plus 1 just be 1/3 x cubed plus x? Yeah, perfect. Just be a little bit careful if you do things this way. Make sure that since I was dividing the entire expression by 4, this coefficient of 1/4 has to be applied to both of these terms. And when I take the antiderivative of these two different terms, I end up with two different terms. It's important that the 1/4 gets multiplied by each of those terms. If you're thinking tack on a plus c, that's good that you're into that habit, but you don't have to because we're looking for any function. We're looking for an antiderivative, not the antiderivative. So you can stop right here if you wanted, or if you don't like parentheses, you can make it 1/12 x cubed plus 1/4 x. Lots of equivalent ways you could also write your answer, but maybe you'd prefer that I just move on to the last example with antiderivatives. Find any function f of x so that f prime of x equals 4 divided by x squared plus 1. Okay, I'm trying to be mean here, right? This looks almost identical to this, so I bet the method that we use is almost identical to what we just did. Nah, not even close. It's kind of a trick question. The idea here is to view this as 4 times 1 over x squared plus 1. So when we're taking the antiderivative, we can pick that 4 and move it out in front and just figure out what is the antiderivative of 1 over x squared plus 1. And if you're like, I don't know the antiderivative of 1 over x squared plus 1, is that, I don't know, some quotient rule with power rules or something? No, you're thinking way too hard. 1 over x squared plus 1 is an answer that maybe you remember from derivatives. It's one of those tricky ones that you're supposed to recognize. It's the derivative of arctangent of x. 1 over 1 plus x squared is the exact same as 1 over, here it is, x squared plus 1. So since the derivative of arctangent of x is 1 over 1 plus x squared, which is equal to 1 over x squared plus 1, the antiderivative of either of these guys is arctangent of x. Our answer is just 4 times the arctangent of x. If we're looking for the antiderivative, we tack on a plus c, but we're not. We're looking for any function, so we're just looking for an antiderivative, so we're done right here. I guess I could have thrown those examples at the end of the last video that ended up being pretty short, but when in doubt, I think more shorter videos is better than fewer long videos. That's all the examples I got. Hopefully those make sense. Let's call this good.